Hello and welcome to this new installment of Built-in Public chess game. In this episode we are going to program the movement of two pieces, the king and the knight. First of all, we are going to make the piece class abstract. So all new pieces are going to inherit from this base class. And let's run the tests. This is going to break a lot of things because we can't instantiate an abstract class. So let me fix this. So instead of instantiate directly the piece class, we are going to create a piece factory class in order to get random pieces already instantiated. Let me start with this random class method to get the classes of any particular piece. So we are going to get a random class from this chess piece constant. Let's go to the main file module, and we are going to declare the pieces constant. We are going to put in there the king class. So let me create an empty class for the king class. We are going to inherit from piece, as we said before. And one important thing, we are going to import all the piece classes just after declare the abstract class. Here, require pieces star. Just include all the files in the folder. So we have to go to the piece spec and substitute all the direct instances of piece class with the random class factory. Here is another one. And the last one. Okay, let's see if there are any error. Undefined piece factory. Okay, this is because I forgot to require the files in the spec helper file. Let me include the factories here. Require factories star. So that should work. Let's run the tests again. Okay. Now we have to fix the board spec file. Let me highlight the piece class. Let me highlight the piece class. So here we are using random pieces. Doesn't really matter the color, so let me create another factory just to create random pieces. Let's call it random. And if we go back to the factory, piece factory, okay, let's create another method called random. We are going to put here a color attribute just to make it possible to select a color, but the default value is going to be nil by default. It's going to return a piece. If we have a nil color as an input, we are going to get a random color between black and white constants that we already defined. Okay, there is a typo here, white and chess color black dot sample. And in the other case, we are going to use the given color. So random class, new, and the color. Okay. Let's back to the spec. And we are going to substitute all the occurrences by the factory method. Let me copy this. And we are going to copy this here. And it seems that there is no more occurrences of the piece. So let's run the tests. And it's failing because of this method, setup new game. I'm going to mark it as a pending and if we run the tests, everything is passing. Okay. Let's talk now about directions. We are going to move a piece in each of these directions. Depending on the rules of the movement of each piece is going to get more or less directions. The important thing here is that we are going to have an array of directions, and each of the elements of this array is going to be an array of movements of the particular piece that we had. So back to the king piece, the king moves one square in any direction, just like this. For this specific position of the king, we have those targets: 2, 3, 2, 4, 3, 4, 4, 4, 4, 3, 4, 2, 3, 2, and 2, 2. And we can compute the relative position as 0, 1, 0, 1, 1, 1, 0, 1, minus 1, 0, minus 1, minus 1, minus 1, and minus 1, 0. We are going to use those relative movements to compute any possible move of the king in any given position. So let's back to the king class to implement all those movements. First, we are going to create a new spec file for the king class. Okay, let me copy the specs here. And we are going to add a new pending test just to check the value of the piece. So let's run the tests in order to see the new specs. Great. Okay, we are going to start testing the king movement in an empty board. So let me create a new king piece. For that, I'm going to use the king class itself. I'm going to create a new board as well. For that, I'm going to use a new board factory with the method empty with a piece in the middle of the board. Just like that. So we are going to create the board factory file in the factories directory. And we are going to create the new method. Let me copy it. Okay. This is going to receive a piece as an argument. Let's create a new board instance. And return the board object. And we are going to declare the middle position, that will be 3, 3. And we are going to use the move method to place the given piece in that position. So that's it. Now we can check the expected possible moves of the king. Remember that the values are that we get before. I'm going to copy the new expected values here. And we are going to check if each of the target positions, if we can move the king to that position. So we are going to call to possible moves method with the given board and return an array, and the return array should contain the expected position. Okay, let's go to the piece class And we are going to implement the possible moves method. This method is going to be shared among all the pieces. It's going to return an array of positions. So let me create here a variable to hold all array positions. We are going to return it, and our initial position is going to be the piece position. And we are going to iterate over directions as we've seen before. So let's make this directions method abstract to be implemented in each piece. This is going to return an array of relative positions for each direction. So now we have to iterate over each direction, and we have an array of relative positions for that direction. And we could calculate the target move based on the piece initial position and adding up the relative position. Initial 0 plus relative 0, initial 1 plus relative 1. Okay, now we have to check if the new movement is valid. We are going to create a new valid move method in the board class. And we'll do something if it's valid. So let's make a break here. I'm going to open the board file or the board class and the board spec files to implement the new valid move method. Let me copy here the specs, and we can start implementing a test to allow to move a piece to an empty square. That is the first spec that we get here. So we are going to create a random piece and an empty board with the piece in the middle using the factory that we already created. We already have created. Our initial position will be the piece position, and we are going to move it into an adjacent square. I don't care if this movement is possible according to the rules of the piece. I just want to check that the board itself allows the movement. So this particular movement should be valid since the target square is empty. Target pose should be true. Okay, let's run the tests, but only the board spec, just to check that the functionality works. Okay, we have an error, and it's failing because our king class doesn't implement the directions method. Okay, let me comment for a while the abstract method. Meanwhile, we implement the valid move method. We run the tests again, and we have a typo here. Let me fix quickly. Let me fix it quickly. Run the tests again, and valid move is not implemented. That's true. So we are going to the board class to implement the valid method. I'm going to accept a piece and a target position, and it will return a Boolean. So let's implement the first condition. We get the target position, and we are going to return true if it's empty. if it's okay. We are going to return true if the target is nil. That means that it's empty. We'll return false otherwise. Let's run the tests again, and it's passing, so we can move to the next spec. We should return true if the target square contains a piece from other color. Let me copy the boilerplate code here, and we are going to specify the color here, white, and we are going to create another random piece that is going to be black. And we are going to put it in the target square. So finally, we can use the valid move method to check it, and it should be true. If we run tests, we have an error because this specific condition is not implemented. So go back to the board class, and we are going to return true if target is empty or target contains a piece and its color is different from the given piece. Okay, let's run the tests again, and now it's passing. Okay, so go back to the spec and implement the last one. Should return false if the piece is moved to one square with a piece of the same color. So let me copy the boilerplate code. And instead of place a new piece, we are going to create a factory to get a board with a piece completely surrounded by pieces of the same color. This is something that we are going to use later. Okay, let's go to the board factory and create a new method. We are going to create a board like this. Let me copy the signature of the method and the board instantiation. We return the board itself, and let me copy the code for create the pieces and put it in the correct position. So let's back to the spec file and check that if we move the piece to an adjacent square, we got false. Okay, run the tests and are passing. Okay, I'm going to implement one last test. It should return false if the movement is out of bounds. Okay, let me copy the boilerplate code. And we are going to put an impossible target, so it should be false. We are going board valid move. Should be false. Okay, run the tests. Okay, it's failing because I put a typo here, Borat. Okay, now it's failing because an exception is raised because we are not controlling that. We are going to put the check here. We are on the tests, everything is okay. So now we can go back to the piece class and uncomment the directions method. So now that we checked the target, we can save this movement to return it. Let me run the tests, the full suite, and we get this error. The directions method is not implemented in the king class, so we are going to implement it. Remember that we already extracted the relative positions here. So I'm going to copy the values here, run the tests again, and another type of possible. Okay, let's fix it. Go to the piece class and change the name possible. Okay, run the tests again and they are passing. Okay, let's continue implementing the king specs. In this case, we are going to see what happens if the piece is surrounded by pieces of the same color. We are going to reuse the factoring method, piece completely surrounded. The king could not move to any square. So if we call the possible moves method in this board, it should be empty. Let's run the tests and passing. Okay, so let's implement the next spec. What happens when a king is surrounded by pieces of different colors? Let me copy the boilerplate code, and we are going to create a new factory to surround a piece with others of different colors. We are going to create a board like this. So let's go to the board factory module and create a new method. Piece surrounded with different colors. Let me copy the signature. The board instantiation. We are going to return the object here, and let me copy the needed code. Okay. In this particular case, the king could move to these squares, capturing the black pieces. So let's write down the new target positions 1 and 2 and 1, 4. Let's go back to the spec file. For that we have to check that the possible moves for the king for that board has a size of 2. So let's run the tests and passing. Okay, get back to the spec and let's continue with the next one. In a board with several possible moves, we should have 7 moves total. Let me copy this. And we are going to make another factory method for a board piece with several possible moves. Let's go to the board factory module. And we have to create a new method as we did before. Let me copy the signature here. and the board class instantiation, return the object, and let's see in this example the board that we are going to build. The king could move to those squares, 7 in total. Let's write down the target positions. 2, 4, 3, 4, 3, 3, 3, 2, 1, 2, and that's it. Let me copy the code to build the board and go back to the spec file to finish the test. The possible moves array should be equal to 7. That's it. If we run the tests, passing, okay. Now we are going to implement the value method. Each piece in chess has a value, so we are going to make it abstract in the piece class, and it's going to return an integer. So let's back to the spec, and according to the game rules, the king piece should have a value of 0. Let me write the test. King value should equal to 0. And run the tests, and fail because we don't have implemented the method in the king class. So let's go to the king class and put the method here. Return 0 and run the tests again, and it's passing. Great. We finished with the king, so let's go for the knight piece. Let's create a new file for the knight spec. We are going to create a boilerplate for every spec, require the spec helper, put the describe, the class here, and let me copy the specs. Okay. If we run the tests, we get an error because we didn't create a knight class. So let's create a new class which inherits from piece. Chess knight inherits from chess piece. And don't forget to put the new class in the pieces constant in the main module. So if we run tests, okay, we have an error because we have to implement the abstract methods. So we are going to put the directions method here, but we are not going to define any body in the method. This should pass the test. Okay, that's it. Now it's missing the value, so we are going to do the same. We are going to define the empty value method, and if we run the tests, are passing. So those are the new specs that we have to implement. So we are going to start with an empty board like the king before. So we have to make a new knight. We are going to reuse the factoring method, empty with a piece in the middle. And we are going to put here the expected target positions. So if we go to the board, a knight moves in those directions, here, 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 and here. Those are the positions. Let's write down 1, 2, 1, 4, 2, 1, 2, 5, 4, 1, 4, 5, 5, 2, and 5, 4. Okay, and the relative positions are -1, -2, 1, -2, -2, -1, 2, -1, -2, 1, 2, 1, -1, 2, and 1, 2. Okay, those are the movements of the knight. So if we go back to the test, let me copy the new positions here, the targets, and we are going to do the same as we did before in other tests. We are going to iterate over those expected targets, and we are going to check that the possible moves are containing the targets. So let me write the test. Knight possible moves. Should contain the expected values. Okay, if we run the tests, are failing because we don't implemented anything in the directions method. So we go back to the knight class, copy the new directions, run the tests again, and now we are passing. So we can continue with the next one. We are going to check that what happens when knight is completely surrounded by pieces of the same color. We are going to reuse as well the factory that we already implemented for the king. Piece completely surrounded. And those are the possible targets because, as you may know, the knight could jump over the pieces. So we could move here, 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 and here. Let's write down the new positions: 1, 1, 2, 2, 1, 5, and 2, 4. Okay, I copied the positions here, and we are going to iterate over each of the target positions in order to see if the possible moves of the knight, the possible moves contains the targets that we defined. So let me write the test. And possible moves for that board should contain the expected value. So if we run the tests, are passing, so we could move to the next test that is going to be the same as this one, because we are going to put a knight surrounded by pieces from different colors. So we are going to reuse the factory that I already have, and the expected targets are going to be the same as before, because the knight could jump over the pieces independently of the color of the piece. So we are going to write the same test again. Okay, knight possible moves for the given board should contain the expected target position. So if we run tests, okay, are passing. And now we are going for the next spec. In a board with different possible moves, we are going to have seven moves, possible movements. So this we are going to change the night color to white, and we are going to use this factory, several possible moves passing the knight. Okay, this is the new board, and those are the movements that our knight could have. There is a movement that is not possible because the other knight is white as ours, so in total are 7 different moves. So let's implement this test. Knight, possible moves for the given board should, size should equal to 7. If we run tests, are passing, so move on to the last test. According to the rules of the game, a knight has a value of 3, so we have to let me instantiate a new knight here. Knight make black, for example. So knight value should equal to 3. Now we are going to run tests. The test is failing because we are not returning an integer in that method, so we are going to put 3 here. Run the tests again, and that's we have 42 examples in 2.5 milliseconds, and that's it for today. Thank you for watching, and see you in the next episode.